Unit 4, Lesson 3. What are we going to learn? When three or more lines intersect at the same point, the point is called the point of concurrency. We're going to learn that there are 4 types of concurrency, and we're going to learn that identifying marks can help determine the type of concurrency. All right, so let's just get in it. Okay, so let's talk about what a point of concurrency is. A point of concurrency, keyword there is point, is where 3 or more lines intersect. So when you have 3 lines, let's say there's a line, here's a line, here's a line. This point where the 3 lines intersect is called the point of concurrency, your POC. That's what I will refer to it as. Now, there's a couple of other things that I'm going to point out throughout the lesson, and that is a couple of words that are going to be important to kind of remember, and that is the word inscribed, INSCRIBED. When you see that word, you should think of the word inside. When something is inscribed, it is said to be inside of something else. And the other word is circumscribed. And when you see the word circumscribed, you should think of the word outside. So when something is circumscribed, it means that it is outside of something else. Okay, so those are some things that we'll refer to once we, or as we move through this particular lesson. Okay, so we're going to focus on using special segments to classify points of concurrency, or POCs. So let's talk about perpendicular bisectors. When you have perpendicular bisectors intersecting, or when the 3 lines intersect and those lines are perpendicular bisectors, that POC is considered to be a circumcenter. CIRCUMCENTER, circumcenter. So let's talk about the identifying marks in this particular figure or triangle with these segments. A box and tick marks will be, if I can write, a box and tick marks will indicate that you have perpendicular bisectors. So here, if you take a look at this segment here, you have a box that says that this segment is perpendicular to this side. And notice that this side has 2 tick marks, so that's what I'm referring to. So why is this circumcenter, why is this point of concurrency so special? It's because the circumcenter is equidistant to each vertex, and we'll stop there. So the circumcenter, this point right here, is equidistant to each vertex. So I'm going to draw that from here to here, from here to here, and from here to here. These 3 distances from this point to each vertex is equidistant. They have the same distance. And the circumcenter is the center of a circle that can be circumscribed about the triangle. Circumscribed. There's that word, circumscribed, about the triangle. So what that means is that this point of concurrency, this POC, which we are calling the circumcenter, is the center of a circle that is circumscribed about the triangle. So here we will have a circle, and because these distances are the same, we know that these three segments will actually be the radius of the circle. And so I can extend this out over here, the same distance, whatever that is, and I can draw this circle. So my circle is not going to be great. I wish I had another tool that I could actually do that with. Be out here somewhere. Okay, not too bad. So here I have this circle that has been circumscribed about the triangle. Ooh, that is so sad. So here we have this circle that is circumscribed about the triangle. So which means that the circle, as sad as this is outside of the triangle. Now, if the circle is outside the triangle, then what we could say is that the triangle is inside the circle. So the triangle is inscribed the circle. Okay, so once again, the circumcenter is special because the circumcenter is equidistant to the each vertex, and the circumcenter is the center of a circle that can be drawn outside of the triangle, and the distance between the center and each vertex is going to represent the radius of the circle, and so that is its circumcenter. Okay? Okay. So now let's talk about angle bisectors. So I'm going to scoot this up. So here we have these segments that are considered angle bisectors. So here we've got these segments, and this segment is bisecting this angle. So it is considered an angle bisector. Okay, when you have segments that are bisecting angle measures, then the point of concurrency, the PoC, is considered to be an in-center. Okay, an in-center. So let's talk about how do we know within a figure if we have if our center or this point of concurrency is an in-center. Well, your identifying marks will be that angle markings will show that they have been cut into two congruent parts. So when you look at this segment right here, I'll start, I'm going to turn my page. So when you look at this segment right here, notice that this segment divides this angle into two congruent parts. Now, how do I know that? Because it has the tick marks saying or indicating that they are congruent. Okay, same thing with this segment. This segment goes through the center, the point of concurrency, and it divides this angle into two congruent parts, which means they have the same measure. And lastly, this segment also divides this third angle into two congruent parts as well. So your identifying marks are that your angle markings show that each angle has been cut into two congruent parts. So why is this point of concurrency, this in-center, so special? Well, the in-center is going to be equidistant to the sides of the triangle. So what does that look like? I'm going to stop right there. The in-center is equidistant to the sides of the triangle. So from here to here, and from here to here, and from here to here, they are, I'm going to kind of highlight that just a little bit more. So from here to here, here to here, and here to here, those three segments are equidistant to each side. So from the end center, from the point of concurrency, from this point, each of these distances are the same. They are equidistant to the sides of the triangle. So, and the end center, this point of concurrency, the end center is the center of a circle that can be inscribed inside the triangle. Okay, so inscribed the triangle. So what does that mean? Well, remember, if these three segments are congruent, then, and we know that these that this point is from the distance from this point to each side of the triangle is the same, and the circle, you have a circle that is inscribed, then what you know is that these segments are considered the radius of the circle. So you have a circle that is inscribed the triangle. So you have this circle that is inscribed the circle, okay? Okay, so moving on to the next, let me slide this away. The next point of concurrency I want to talk about is this idea of a median. And a median, this point of concurrency right here is going to be considered a, what is this called? This is called a centroid. So, this particular point this point of concurrency is going to be considered a centroid. Okay, now the identifying marks are going to be that the segment comes from an angle and divides the opposite side into two congruent parts. Okay, so let's put that in perspective. So looking at this segment coming from this angle, this segment, notice it goes through the center, and when it meets its opposite side, this is considered a medium, not a medium, this is considered a median and divides these two sides, or this side, into two congruent parts. So this length is going to be the same as this length. And that is true with the others as well. So notice that this segment comes from an angle and it divides this side into two congruent parts. And then same thing with this. This angle, this segment comes from an angle, goes through that point, and divides divides this side into two congruent parts. And so the marks will label the congruent parts. So this is a centroid. This is special because the centroid is the center of mass and is the geographical center of the triangle. So this point of concurrency is also considered the center of the triangle. All right, and these are created, this center point of concurrency, that is considered a centroid, and centroid is this, the specialness of it is the fact that these segments come from an angle and divide the opposite side into congruent parts. Okay? All right, now let's talk about altitudes. So an altitude is what we will be focusing on here. When you have altitudes within your figure or your triangle, then this POC, point of concurrency, is considered to be the orthocenter. Okay, orthocenter. All right, so the identifying marks are going to be that altitudes, many times we will call altitudes heights of the triangle, come from a vertex and are perpendicular to the opposite side. Okay, so I'm going to stop there and let's look at this. So I have a segment which we consider to be an altitude that comes from an angle, and the altitude is perpendicular to the opposite side. Excuse me just a minute. And notice that we have this box that indicates that this is a right angle. And so that's what tells me that this is an altitude and is perpendicular to this opposite side. Same thing here. We have this segment, which is considered to be an altitude that intersects or is perpendicular to its opposite side and is indicated by this box. Same thing here. We have another segment drawn from this angle to its opposite side. It is perpendicular to its opposite side, and we see that because, or we know that because of the box. Okay, so interesting enough, why is this point of concurrency special? Well, it's simply special because it exists. Okay, when you have three altitudes in a triangle, the point of concurrency is what we consider the orthocenter. Okay, so if you think about, if you've ever had braces, then what is the purpose of braces? What is the purpose of braces? If you have braces, then you've gone to an orthodontist, if I can spell. An orthodontist straightens your teeth, so straight teeth, or straightens teeth. How about orthopedic? If you've ever had a broken bone, you may have had to go to an orthopedic, and I don't know how to spell this. I know it's spelled kind of weird. Okay. Anyway, orthopedist straightens bones. And so there's also other kinds of words in our vocabulary that have this ortho in it. And ortho means straight or upright, okay? So these are the different types of points of concurrency and their special characteristics that indicate what type of concurrency it is. So here's a cute little mnemonic device, which is something to help you remember what the identifying marks are and what type of point of concurrency it is. So Miley Cyrus ate Oreos, peanut butter, and chocolate chips after breakfast in class. Okay, so what does that mean? That means that M for medians are the point of concurrency are created by medians, and that is a centroid. A for ate Oreos would be altitudes, which would be orthocenters. Now, peanut butter is for perpendicular bisector, and when you have perpendicular bisectors, the point of concurrency will be a circumcenter. See? And then finally, angle by AB is an angle bisector, which the point of concurrency would be an incenter. So these are the different types of behaviors of the segments, and these are the types of points of concurrency. Okay, so to wrap this up, what are the takeaways from this lesson? The takeaways are circumcenters are equidistant to each vertex. When you see the word circumscribed, you need to think of the word outside. And when you see inscribed, you need to think of inside. Now, medians, there are other, we also need to remember that medians, divide the opposite sides into two congruent parts. I should have added that to my list. Okay. All right, so special segments and points of concurrency.